Okay, hello. I want to take this privilege to also welcome you to my channel. The name is Professor Doctor. That's the name on my channel. So please help, share, subscribe, comment, every mistakes. Let me know. This channel is for all of us. So let's try to promote my channel. So from our previous lessons, we've solved a lot of questions on Bernoulli, Riccati, linear differential equation separable. So today the question on board is that we should solve the ordinary differential equation y prime plus 2 over x y equals x square x multiplying y exponent 3. So this is general, right? Because this is not a linear differential equation. Why? Because for linear differential equation, all the conditions must satisfy. And from our previous lessons, we saw some of the conditions for a linear differential equation. And we also know some of the rules on Bernoulli equations. So this is a Bernoulli equation. This is a Bernoulli equation. This ceases to be a linear equation because of the y exponent way. So the y exponent n. So it could be 1, it could be 2, it could be 3, it could be 4. And we've already known that it's the maximum power for y, or for the equation to be linear differential equation, is that the y, in case there is y, it should be 1. And even in this y, the dependent variable, it shouldn't multiply the derivative. So that was just by the way. So this is the general form for Bernoulli equation. That's y prime plus p of x y equals q of x y exponent n. So I can compare this to the general equation for Bernoulli. So I see they are almost the same. So here's my y prime, my q of x. That's the 2 over x. This y, my q of x. This my x square, my y exponent n. This y exponent 3. So I can boldly say my n is equal to 3 because my y exponent n here, my y exponent 3. So my n is equal to 3. My q of x is equal to 2 over x. My q of x is equal to x squared. So comparing, I just compare the Bernoulli equation to the differential equation that was given. So after that, we find the integral factor. The integral factor mu is given by e exponent integral of 1 minus n multiplying p of x multiplying dx. So my e exponent integral of the n is 3, so just make a substitution. My p of x is, sorry, where's my p of x? My p of x is 2 over x, so just make a substitution here. So make a substitution here. So after making the substitution, you are going to get e exponent integral of 1 minus 3 is minus 2 multiplying 2 over x dx. So you are going to get e exponent minus 2 times 2, you are going to get minus 4 over x. But minus 4 is a constant, so minus 4 can come out from the integral sign. So minus 4 will come back, then we integrate with respect to 1 over x. So when you find the integration of 1 over x, you are going to get ln x. You are going to get ln x. Later, when we integrate 1 over x, you are going to get ln x. So you are going to get minus 4 times ln x. But the minus 4 will come and be as an exponent of the x. So you are going to get mu to be equal to x exponent minus 4, because the minus 4 which was supposed to be here will come to be an exponent of the x. then the ln will cancel the natural log. Then you are going to get mu, that's the integral factor, to be x exponent minus 4. So this is the general equation we consider for Bernoulli. So from the general solution, we consider this equation, that's y exponent 1 minus n is equal to 1 over mu multiplying the integral of 1 minus n bracket close multiplying q of x multiplying the mu, that's the integral factor again, then dx plus c. So just make a substitution as we did for the previous one. We're going to get y exponent 1 minus 3 because our n was 3 is equal to 1 over x. The mu we obtained the mu to be x exponent minus 4. So I can get 1 over x exponent minus 4 multiplying the integral of the same thing, 1 minus 3 x squared multiplying x. No, my q of x. Note that the q of x was x squared from the equation. Then my mu is x exponent minus 4 dx plus c. So y exponent minus 2, because 1 minus 3 is minus 2. I'm going to get y exponent minus 2 is equal to x exponent 4. Because this is 1 over x exponent minus 4. So when x exponent minus 4 goes up, it becomes plus, positive. So the negative sign will change to positive. So you're going to get x exponent 4 multiplying the integral of 1 minus 3, which is minus 2, x squared multiplying x exponent minus 4 dx plus c. Then my y exponent minus 2 is equal to x exponent 4 multiplying the integral of minus, so this x squared and x exponent minus 4 is multiplying. So you just take one of the x, then you add their coefficient. So 2 minus 4, we are going to get minus 2 dx plus c. So we are trying to integrate minus 2x exponent minus 2. So what we intend to do is that you add 1 to the minus 2, then you divide by the result. When you add 1 to, we are going to get minus 1, then you divide by minus 1, so plus c. That's how we integrate. So we are going to know that the minus 1 will cancel the negative here. We are going to get 2 over x plus c multiplying x exponent 4. So my y exponent minus 2 is equal to, we are trying to multiply the whole this equation by x exponent 4. So we multiply x exponent 4 by 2 over x. The x is, one of the x is going to cancel one of the x exponent 4. So we're going to get 2x exponent 3. So that's how we had 2x exponent 3 plus cx exponent 4. So we can leave our answer like this, but this norm is not more appreciated because the y exponent minus 2 is, we have to get the y to be alone without any exponent. So more or less this can be written as 1 over y squared equals 2x cubed plus cx exponent 4. So I can multiply 2 by y squared. So multiplying 2 by y squared, I know that this y squared will cancel y squared. Then this y squared will just multiply in this. So remember, we are trying to simplify our result. So this is simple mathematical equation. So don't try to multiply the whole of this equation by y exponent 2, because when you do that, we are making the solution to be complex. So just leave it like this. So after multiplying to this, know that the whole of this place is going to remain 1, which is equal to the whole of this place multiplying y exponent 2. Then we divide by the 2x exponent 3 plus cx exponent 4, both sides. So you divide both sides by 2x exponent 3 plus. So you know that my 2x exponent 3 plus cx exponent 4 will cancel 2x cubed plus 6 cx exponent 4. So I'm going to get y squared is equal to 1 over this 2x cubed plus cx exponent 4. So I can say I can multiply 2 by x. Sorry, I can multiply 2 by 1 over 2, because I know that here the exponent, to clear the square, I can multiply 2 by half. So multiplying 2 by half, I'm going to get the 2 here, we're going to cancel the 2 here, so we're going to get y. Then 1 over 2x cubed plus cx exponent for all exponents half. Remember, you multiply 2 by half. So this can be written as 2x exponent minus 3, because when this 1 over this, so the whole of this one, it goes up, it becomes 2x exponent minus 3 plus cx exponent minus 4. Then the half is a square root, so square root of this. So this is more or less more appreciated than this. Thank you very much.